All right, in this lesson, we're going to be looking at sine and cosine curves. And I have a graph here showing both of those. We have the sine curve and we also have the cosine curve in the dashed line. And you can see that the curves are the same shape. They're the same height. Okay, so the center of both the parent functions of these curves is right on the x-axis. So they're both going to 1 and negative 1. Translating the cosine curve pi over 2 horizontally to the right would make it identical to the sine curve. Both functions complete one period in 2 pi radians. Okay, so one period means we're going to take the curve, we're going to look at the curve, and we're going to see where does it start repeating. It starts repeating, both of these curves start repeating at 2 pi. So the period of both of these functions is 2 pi. Both functions are periodic, meaning they repeat the same cycle of values. And the amplitude is half the difference of the maximum and the minimum values. What you have to remember is the amplitude is the distance from the center. The amplitude is the distance from the center. It's helpful sometimes, I think, to think about the patterns when you have to sketch a curve. The sine pattern has a 0, max, 0, min, 0 pattern, and the cosine pattern has a max, 0, min, 0, max. If we look at sine and cosine curve transformations, the absolute value of A is the amplitude, that's the distance from the center. 2 pi over b is going to give us the period of the function. B is the number of cycles per 2 pi. C is the phase shift, or what we sometimes refer to as the horizontal translation. D is the vertical translation. If the value of A is less than 0, we reflect over the x-axis, and if the value of B is less than 0, we reflect over the y-axis. All right, so let's get right into looking at some of these different sine and cosine curves. So example 1, it says write down the period and amplitude and find the equation of this function. All right, well, first of all, period can be found by determining how many cycles occur in 2 pi. So we've got 1 cycle, 2nd cycle, and the 3rd cycle. So B is 3 in this example. Now the amplitude, as I said, is the distance from the center. So what is our distance from here to here, or from here to here, right? That distance is 0.5. So our amplitude is 0.5. Now the last part says find the equation of this function. Right, now the sine function, it starts right at 0, so we have no horizontal translation, and it hasn't been shifted. The center is at 0, so we know we have no vertical translation. So let's first write out the equation for sine, and we already know that C, we said that our value of our horizontal translation is 0, so this value is 0. And our vertical translation is 0 because our center is at 0. So we can ignore the C and D part of this equation. The value of our amplitude is 0.5. And we said B, our number of cycles, is 3. So that's our final answer there. So we have our period, 2 pi over 3, amplitude 0.5, and we have our equation. All right, let's take a look at example 2. Let f of x equal sine pi over 2x, and we're looking where x is between 0 and 4. Write down the amplitude. Whenever you see write down on an IB exam, it means that you can look at the equation and know the answer. There is absolutely no work. So we know that this is the value of A. This is our amplitude, and this is the value of B. This is our number of cycles. So A is just 6. And then to find the period of f, we're going to do 2 pi over b. And we know that b is pi over 2. When you divide by a fraction, you're going to multiply by the reciprocal. So that gives us a period of 4. Now we're being asked to sketch the graph of the cosine function. All right, we know that this is our amplitude, this is our number of cycles. I think it's helpful to write down our pattern. The pattern for cosine is max, 0, min, 0, max. We know our amplitude is equal to 3, so remember, amplitude is the distance from the center. Our period is 2 pi over b. So in this case, 2 pi over 2 gives us a period of pi. And we have no phase shift, so we have no horizontal translation, no phase shift, and we have no vertical translation. So in other words, when I say there's no phase shift, I don't have anything with x. I don't have x plus or minus a number. And when I say there's no vertical translation, there's nothing on the outside plus or minus a number. So when we say there's no vertical translation, that's a very helpful bit of information because that means that our center is at 0. And we want to look at this between 0 and 2 pi. And just keep in mind now, one period is going to end at the value of pi. So we're going to have 2 cycles of this graph happening. Now, I usually like to just mark up with a dashed line my center and then my maximum and minimum. So my center is going to be right at 0. And my distance from my center, my amplitude is 3. So I know this is the top of my graph. And the bottom of my graph is at negative 3 because my amplitude is 3. Now, I'm going to go to pi, and I'll have to go, though, it says graph this function all the way to 2 pi. So let me mark this up. And remember, our pattern is max, 0, min, 0, max. So that's going to end at pi. And then we start at where we ended, max, 0, min, 0, max, 2 pi. All right, I'm going to put my dots now, put my markers. Max, 0, min, 0, max, max, 0, min, 0, max. Draw your graph. All right, that's it for number 3. All right, for example 4, it says sketch the graph of y equals 2 sine x plus pi minus 1. So our amplitude is 2. Amplitude is our distance from the center. Our period is 2 pi over b. The value of b right here is 1. So in this case, it's 2 pi over 1, or just 2 pi. This x plus pi means we're moving the entire function left pi. The phase shift is also referred to as the horizontal shift. And then the last part of this, we have this minus 1 out here. That means we're moving the whole function down 1. So we have a vertical translation down 1. That means our center is at negative 1. All right, so the trickiest part of this, I think, is that we're moving the whole function left pi, and then the period's 2 pi. So we're going left pi from 0, and then the whole function is 2 pi. One cycle of the function is 2 pi. So we're going from negative pi to pi. This is pi, this is pi, that gives me 2 pi. Right, and that gives me 5 marks for my pattern. That would be 0, max, 0, min, 0. And I'm trying to sketch this graph between 0 and 2 pi. So I have to keep going. I have to draw at least another cycle. I have to do pi plus 2 pi, which is going to give me 3 pi. Right, so I would repeat my pattern here. It would be 0, max, 0, min, 0. And between pi and 3 pi is 2 pi. Right? We know that we have a vertical translation down 1, so we know that our center is happening at negative 1. Our amplitude is 2, so the distance from the center is 2. So up 2 and down 2 from the center. And then we can go ahead and sketch in the graph. So my pattern again is 0, max, 0, min, 0, 0, max, 0, min, 0. Right, and I'm just gonna do dashed lines until I get to 0 because I'm only sketching from 0 to 2 pi. So I'm just gonna highlight that to reinforce it. This is the sketch of that graph between 0 and 2 pi. And that's it for example 4. Okay, so for example 5, we're using a calculator. And notice that when you look at the function, you don't see a degree symbol. So we're going to assume that we're in radians. And it says to sketch this graph between 0 and 6. So we're going to open the calculator. We're going to make sure we're in radians. We're going to go to mode, and then you go down to radians, you select that, hit enter, and then we'll click. We're going to go to y equals, and we're going to enter our function. And then we want to look at the table of values, and we're looking between 0 and 6. So you may want to set your table. We're going to go to second window to do that for table set. We want to start at 0, and we want increments of 1. Right, now that we have that, we can look at the table. We do that by going to second graph. All right, and now we have our values for 0 through 6. So let's write those down, and we'll round those to the nearest hundredth. And now that we have those values, we're going to go ahead and plot them and sketch our graph. And if you notice, the y values aren't going anywhere greater than 1. So I'm going to make my scale on my y-axis go by 0.25. And then we'll go ahead and plot the points and sketch the graph. All right, we have a nice sketch of our graph. Part B, they want us to write down the x coordinates of all minimum and maximum points and give our answers to 4 significant figures. So at this point, because we're going to be looking at the minimum and maximum, we want to set our window in our calculator. So we're going to have a x min at 0, x max at 6, scale of 1. And we can tell that our y is only going to 1. So I'm going to start y at 0 and go up to 1. And I'm going to make my scale 0.25, just like I did when I drew the graph. So let's do that in our calculator. So here everything is entered in the window, and if we don't do this ahead, when we look at the graph, we're not really going to be able to see those maximum and minimum values. So let's just hit graph. And you'll notice that we have 2 minimums and we have 2 maximums. So we're going to use the calculator now to find those values. We're going to go to second trace, and the first value we're looking for is a maximum. I'm going to move my little spider over to my first maximum, and we need to be a little to the left. Hit enter, a little to the right, hit enter. When it says guess, hit enter. And so the first value we get is 0.6075. Right now we're going to find the next one. Move our spider to the left, hit enter. Move our spider a little to the right, hit enter, and then guess. And the next value we get is 1.571. Find the next value. It's a maximum, second calc, number 4, little to the left, hit enter. Little to the right, hit enter, and hit enter. And we get a maximum at 2.534. The last one is a minimum, second calc, number 3. Hit enter, move to the right, hit enter, guess, hit enter. And we get 4.712. All right, that's part B. Moving on to example 6. Again, we're using our calculator. We should be in radian mode. Because there's no vertical translation here, there's no value outside here, right? Moving the function up or down. We know that the center of the function is 0. And the distance of the function, and the distance from the center of the function is the value of a, and the value of a is 1. So the center of the function, we'll do a quick note here. The center of the function is at 0. The amplitude goes up 1 and down 1. So the minimum value is just going to be -1. Now the period of function g can be found by doing 2 pi over b. So it's going to be 2 pi over, and the value of b is the value in front of x, that's 0.5 or a half. I'm going to write it as a half. When we divide by a fraction, we multiply by the reciprocal. So the period of this function is 4 pi. And then lastly, we're going to solve for f of x equals to g of x. So if we put that in our calculator and we find the intersection, then we should be able to easily solve that equation. So we go to y equals, we put in the first function. We're going to go to y sub 2 and put in the second function. And then we need to set our window. So I'm going to use a feature called zoom trig. I'm going to go to zoom. I'm going to choose number 7. That's zoom trig. And it's asking us to look at this function between 0 and 3 pi over 2. So I'm going to go to window, and I'm going to be looking at it from 0 to 3 pi over 2. And I'm just going to leave my scale as is. And you can see we have 3 intersection points. We've got one here, and one here. So we're going to calculate those intersections. Second trace, number 5 for intersect. Move the spider to the nearest the first intersection, hit enter 3 times. So the first intersection happens at 1.26. Go back, second trace, number 5. Move the little spider near the next intersection point. Hit enter 3 times. First curve, enter. Second curve, enter. Guess, enter. And we get a value of 3.77. And the last one, second trace, number 5. Just move near that intersection. You want to be nearest to the intersection you want to find. Enter 3 times, and this time we get 4.19. Okay, that's it for this lesson. Thanks for watching.